in chapter 15, we got our third tool for working with kinetics. This tool was obtained by manipulating Newton's second law. And when we did that, we found this expression, mv1 plus net of these guys, integral f dt over some time interval, let's say t1 to t2, is equal to mv2. Now, terms like this we called a linear momentum, and terms like this we called a linear impulse. Okay, so this is the initial linear momentum, and this is the final linear momentum, and if they're different from each other at all, there must have been some non-zero linear impulse. And we did in class, and it's in your book, describe this useful tool called a momentum impulse diagram. So taking just like the three terms we have here and making cartoons with each, if this is my initial momentum, mv1, and I think about adding some action by a force on my particle, maybe I have some force pushing down, some net force that acts over this time interval, I will get, or this is equal to, some new momentum. Drawing these diagrams can really help you in solving problems. And if we consider all particles and impulses that are involved, if we track them, if our window is big enough to see all of them, that is, if we have no external impulses, then we can say that we have conservation of linear momentum. I'm careful not just to say conservation of momentum, because we do want to distinctly talk about linear from angular momentum, and that's what we'll be getting soon. So conservation of linear momentum, in that case, basically, we don't have a term like this. That didn't mean, you'll recall, that we didn't have any impulses, just that they canceled out with each other, because we had the impulse A exerts on B canceled out by the impulse B exerts on A. So in that special case, we have, let's just jump right to the version that we would have for multiple particles. It's obvious how this reduces to one particle if that's all you have. So if I added up all of my MIVI's before, and I also added up and because they would all, the interactions between the ith and the jth particle would all both be captured, then we have simply that this is equal to, sorry, that's that equal sign. We have that this is equal to the net momentum afterwards, the net linear momentum afterwards. So that is the sum of all MIVI's after. That's it. That was the conservation of momentum notion, and in the case where we don't have conservation, we have some external force, we can use the full form of the equation. And we went on to talk about one special application, which was collision. So in collision, we started by defining a couple of terms. We defined a central impact, an oblique, give myself a little more room, oblique impact, and lastly, this notion of a line of impact. This is in your notes, but again, suppose we have a line of impact at some angle like this. And this would be the kind of perpendicular to line of impact, and if we have two particles that are ultimately going to touch at points that are along and oriented with this line, so they're, let's say, coming at each other like this. What we found is that the momentum, let's call this the u1 direction and this the u2 direction. The momentum in the u1 direction for this system will be the same before and after. The momentum for this system in the u2 direction will be the same before and after. The kinetic energy for this system in the u2 direction will be the same before and after, but in this line of impact direction, some of the kinetic energy is lost, and the extent to which it's lost was dictated by this equation. So this is a coefficient of restitution, and its magnitude, which is between 0 and 1, is given by Vd prime minus Va prime all over Va minus Vd. So Va is the velocity of my eighth particle, and Vd, the velocity of the bth particle, particle b. And the primes denote after the collision, whereas the regular notation is for before the collision. You should have had a chance to practice this in the homework. Just remember again to separately handle the line of impact from the non-line of impact components. And that's it so far for Chapter 15.